Hi, everyone. Dr. Tim and Hillary for another Dr. Tim's Aquatics podcast. How you doing this morning, Hillary?
I am doing good.
All right. So today we are going to have a discussion about bacterial additives. And this was kind of spurred on by a post on one of the more popular forums. And the poster had taken this quote about, it said something about people that have septic systems know that you don't have to add bacteria to these septic systems if you have a healthy system. But then they had crossed out septic and put reef, implying that you really don't have to add bacteria to a reef tank if you have a healthy reef tank. Of course, the operative word in both cases is reef. But what I wanted to talk about is I kind of wanted to counter that because comparing your reef aquarium to your septic system is a false analogy. So that's what I'm going to jump into. And let's get down the rabbit hole. How's that, Hillary?
Oh man, we're just starting off strong.
Yeah, we're just going for it. I'm in that mood today.
All
So,
right.
so one thing, the main reason, and I'm not going to talk a lot about septic systems, but you can buy bacteria for septic systems because obviously if it's healthy, you don't have to do anything with it. But comparing a septic system to an aquarium system is very different, namely because what do we have in our aquarium systems? We have lots of devices that intentionally and unintentionally remove bacteria from the system. And you need these devices to one degree or another. So I'm talking about UVs. Septic systems don't have UVs. We have UVs. If you have a fish only system, a UV can be important. Now, I've talked about it in numerous podcasts. There's always a trade-off. You're trying to keep disease organisms down, which can proliferate, especially in heavy fish systems that are fed a lot, and a UV can work. But the downside is you're probably also going to be killing the beneficial bacteria that are in the water column. I'm not talking about the nitrifiers. I'm talking about the bacteria that consume nutrients. So sometimes fish systems which have a large input of organics and phosphates and then nitrates, because you're feeding a lot. Fish, you feed a fish only system a lot more than you feed a coral system. So if you use a UV to control bacterial populations in the water column, you're going to be killing the bacteria that would consume those nutrients, and that leads the system maybe towards having more cyanobacteria outbreaks, anything that lures, or hair algae, green hair algae, stuff like that, because nutrients are going to be utilized by something. If you eliminate the bacteria in the water column, things that live on surfaces, cyanobacteria, hair algae, things like that are going to grow. So you have to take other measures. But if you realize that and understand that, you can counter those measures. Protein skimmers. I've never said don't run an aquarium without a protein skimmer. What I've said is put your skimmer on a timer. You need protein skimmers. We need to export organics from the system, which is what skimmers do, but unintentionally, they are really good at removing your bacteria. So try running a septic system but removing the bacteria on a 24/7 basis. Your septic system's not going to work very well. But we need that skimmer to a certain degree. We have to understand the negative or potentially negative drawbacks of that skimmer and then take countermeasures, which is why we add bacteria. Roller mats, filter socks, all these devices are necessary to one degree or another, but they're removing the bacteria population from the tank. So to counteract that, you need to add bacteria. And the other part of this post was about like diversity. And that's a big buzzword now. is people want to increase the diversity of their aquarium. And this is problematic because there seems to be a general feeling that environments tend towards increased diversity, and that's not true. Whether we're talking about microorganisms, microbial ecology, or redwood forest, there's not a lot of diversity if you look at a redwood forest. There's not a lot of diversity if you go out in the middle of America and you see that those beautiful waves of grass. I'm not talking about wheat, but the fields that are out there that naturally occur. Environments generally tend towards less diversity. You have these colonizing species that get in real quick, and then they're slowly replaced by a climax community, climax forest, something that's going to be very stable until there's a perturbation. And that's a general misconception amongst people, is they think that, well, you want naturally a lot of diversity, and that's not true. And your aquarium is always tending towards less diversity. Whether that's good or whether that's bad depends upon what you do. And why I bring that up is studies have shown, Sanjay Joshi did a nice study on skimmers that showed that not only do skimmers remove bacteria, but they remove certain groups preferentially over others. So you're turning the system artificially to favor one group of bacteria, and it may not be the bacteria that you want. So things are more complex than they seem. And just because, so that what that means is that if you're adding a mixture, and here I'm kind of agreeing to a certain extent with the person that posted this, just because you're adding a mixture doesn't mean that that mixture is going to help, because there's several things at play here. One, does the mixture even have diverse group of bacteria in it? And that's easily tested nowadays with genomic testing. And if you were to look at a lot of these bacteria mixes, you're going to find they don't have any diversity. It's basically monospecies or a couple of species. And if you all know, I grow bacteria. If you looked at ours, you're going to see there's many species, up to 8 species in there. We're talking about our waste away and our eco balance. And more important, or just as important, is our bacteria were originally isolated from our aquariums or our ponds. That's where we got them. A lot of companies, that's not the case. They literally buy bacteria from a bacteria production company, and a lot of them use grease trap bacteria, which restaurants put down the grease trap to consume that, so they don't become clogged. The grease trap doesn't become clogged up. They're not aquarium bacteria. And especially with our nitrifiers, I've said many times, our nitrifiers aren't going to work in a sewage treatment plant. The nitrifiers that we grow are originally isolated from aquariums. They grow in low ammonia, low nitrite environments. So they can't be used in every environment in which there's ammonia or nitrite. Bacteria is like fish. You can't throw certain saltwater fish in freshwater and vice versa. That's not the environment they grow in. So just because, it's just a fact of life, folks, that not all companies are reputable, and they're selling you what the thing of the day is. Well, now they're, a couple of years ago they were chemists, and now they're microbiologists, and now they're microbial ecologists, and trying to sell you that they've got all this diversity and diversity is good and blah blah blah, and that's just not happening. And then the other factor is, and here I can agree to a certain point, but there's operative words here. If that's the big thing, if you have a stable, mature aquarium, and I think people that have been in this hobby for a long time will recognize this, that during the first 6 months to a year of setting up a reef tank, it goes through a lot of changes. And then at some point, something happens. And the more you don't interfere, the more you don't change things and get in there, you've got to keep the parameters right. But I'm saying, getting there and messing things with your hands and rearranging things and adding this and adding that. When you back away from that, at some point, the tank almost seems to run itself. It just gets very stable. And I've had this happen many times. And then your job as the aquarist, you make sure your calcium and your magnesium ratios are good. But some people say, well, I haven't changed my water in years. And you're like, well, how's that possible? Well, maybe they weren't adding a bunch of fish. We were talking to reef tanks to a certain degree. And they've cut down on the amount of food they're adding and all those inputs, and the tank achieves stability and it just looks really great. Well, if you add bacteria to that tank, is it going to do much? And the answer is we don't know for sure, but it seems that all the niches, the places that the bacteria could get a foothold, have been taken and they're occupied. And that's what I'm talking about, is just because you add a mix to the tank, if there's not a resource or a niche the bacteria can utilize, then they're probably going to be flushed out of the tank and not become established. So it may not be the manufacturer's fault on that. People want to keep a stable tank, but just because you add it doesn't mean they become established. So you have to be careful with that. And then sometimes, if there are niches available, just because you add it, maybe it doesn't happen what you want. And this can be the case when people are adding some type of vodka dosing or organic, because they're thinking, well, I want to grow this bacteria, and so I'm going to add this organic because that's what's missing. And then what happens? Well, they start growing all sorts of cyanobacteria. And how'd that happen? Well, you added this fuel, and this fuel doesn't just go to, it's not specific for one type of heterotrophic bacterium. It can be used by everybody. You've added it, you keep on adding it, and I see this a lot in cyanobacteria tanks. The tank is already covered in cyanobacteria. As I've said many times, it's a numbers game. So the team cyanobacteria is wiping out everybody and is become established. And I've heard this literally hundreds of times for going to trade shows. Now, we started Dr. Tim's Aquatics. We started our 18th year this year. So I've been to a lot of shows. When I say trade shows, I'm talking about the Reefapaloozas and the Aqua Shows and MECAs, where you talk to people and things like that, hobbyists, which I love to do. And the common advice is, oh yeah, get a bigger skimmer and add some organics to my tank to combat cyanobacteria. And most of the time people say it only made it worse. Why? Increasing the skimming rate, increasing the amount of skimming, removes bacteria from the water column. And at the same time, you're adding this organic carbon, this fuel, vodka, whatever it is. Well, the heterotrophs, all heterotrophs want that. And cyanobacteria are heterotrophic. So you're feeding the cyanobacteria. So they grow like crazy because you're feeding them and you've eliminated their competition. Thank you very much. And so that's the wrong approach. If you want to get rid of, long-term, want to get rid of a group of bad bacteria for cyanobacteria, you have to have a perturbation, a change, a force. And you're that force. That's why we say in our directions, manually remove as much of that cyano as you can. You're taking charge now. You're going to get rid of that cyano and try to change the balance. And instead of the cyano being on top and ruling, get rid of them and then add good bacteria like our waste away, which are from aquariums, and get them to reestablish a stronghold. And it doesn't mean it's always going to work. It generally will work, but you have to have the water quality where it needs to be. And again, I've talked about this. If you don't change the water chemistry, cyanobacteria dominate in tanks with a lot of organics, low nitrate, and medium to high phosphate. If all you do is get rid of the cyano physically and add some waste away, chances are the system is naturally going to head back to be dominated more by cyanos because the water chemistry overrides everything. The good bacteria and waste away can't really grow very well because the tank doesn't have the nitrate. And what's the nice trait about, I mean, nice for them, cyano, is they can get nitrate right from the atmosphere. They don't need it to be in the form, or they can get their nitrogen from the atmosphere. They don't need it to be in the form of, say, nitrate. So the perturbation is important, but the environment has to be right. And one of the biggest parts of this, Hillary, was the Earth used to be dominated by dinosaurs, and then the meteor hit. We didn't get dinosaurs back. That became eventually the age of mammals. Why didn't the dinosaurs come back? I've never read. I mean, it was dominated by dinosaurs. We get the blackout from the Earth, from the meteor hitting the Earth. The dinosaurs died back. What changed that now mammals became dominant? And you got to remember, folks, humans, mammals really didn't appear humans were never in at the same time period as dinosaurs. And this is maybe that's a stretch of analogy, but that's what you're trying to do here. If you don't perturb the environment when it's in the wrong phase and you're just adding something, chances are the environment's not going to change because the niches are already taken over. It's reached that, what they call that climax, that stable community, and you've got to change things. That's, as I began this, that's what nature wants, is to go to less species and bigger numbers of those fewer species, bigger members of those fewer species that dominate. You see that pine forest, redwood tree forest, even in some types of coral reefs have battle with each other. You've had that, the corals sting each other, they're fighting, and you can get these almost mono forest of corals, which in pictures look great, but there's not a lot of diversity there. So it's a false connotation that systems naturally want to be diverse. It's also false that systems that have a huge amount of diversity are more stable. That's not always the case either. And then you have to be adding the right types of bacteria, but the environment has to be correct, as we've said, or as I've been talking about. If you're trying to get rid of dinoflagellates, what is almost, I'd say 95 out of 100 times when people say their tank is dominated by dinoflagellates, their nitrates and their phosphates are really low or zero. That is a perfect environment for dinoflagellates. And you can change it temporarily, but long term, you've got to change the environmental parameters, the water chemistry, in order for it to become more dominated by heterotrophic bacteria in the water column and clean out all those dinos and things that are growing in the substrate that make the tank ugly. Did I say that all in one breath, Hillary?
I think you did. You condensed like a 45-minute podcast into 15.
Sorry, I was speaking really fast, wasn't
I? I feel like every time we talk, I always learn something that makes a lot of sense. Like, we all talk about how good having a lot of biodiversity is, but in reality, like, systems don't want a lot of biodiversity. There's, like you said, specific niches to be filled. Once those are filled, that's it.
Right, and to get another organism, has a very difficult time taking over that niche because it's already occupied. Can it happen? Yes. I mean, and we see that with invasive species. But the fact is, every day, invasive species come to a new environment, whether it comes from shipping or just bilge water or whatever, and they don't always occur. Yes, it occurs, and yes, it's a big problem, but nature is rather resilient to that change. Generally, something has to happen. And unfortunately, in these modern days, that something that happened is man got involved, and we eliminated something that opened up a niche, and that allowed these invasive species to get a stronghold.
At least for me, that just opens up a huge can of worms, especially when it comes to, I mean, this is taking a step away from aquariums, but like wildlife management and conservation. Like, if there are impacts that we as humans, like things that we have caused that have allowed invasive species to come in, and they've kind of filled that niche, where does our responsibility lie to take that back out of the environment? Or like, is it our responsibility? Do we just leave it? Or I wonder about these things all the time.
Well, no, a lot of people wonder about these because, and not only do you leave it, but do you compound the problem by trying to fix it?
Yes, exactly.
Yeah.
And a good example.
Go ahead. No, go ahead.
I think a good example of this, at least that I've been thinking about recently, is down in the Florida Keys. The water temperatures have been so warm, and I've had people ask me like, "Oh, what do you think we're going to do? Are the corals going to make it?" I was like, "Well, corals can adapt to a lot of things over time if they're given enough time. But maybe the answer is moving a little bit further north. But then our responsibility, like, should we be moving corals out of their native habitat, even if it's into a habitat that would be better suited to their needs? Like, back to the, like, where do you draw the line? What would be the better solution for stuff like that?"
Right. And there are huge conferences and papers and discussions on that, even to the point where you take the corals out and you culture them in labs. Do you put them back? Are they natural? Once you've taken them out and cultured them, and where do you put them back, and which ones do you put them back in ratios and things like that? And there's no simple answer to any of that.
Ones that you've grown to be resistant to bacteria and diseases and all sorts of stuff. Oh man, adding more layers to this.
Yeah, and you almost start to get into these Marvel or whatever it is movies where are you rewinding things and playing, choosing others, and then what are the unintended consequences? And that's always the bigger issue, is what is the unintended consequence? And can you think of all those unintended consequences, and are they bigger than the problem that you were trying to solve?
Be playing Thanos and just snapping our fingers.
That's it. The point that I was trying to get across is, well, there were several points. One is there is a general lack of knowledge on ecology and microbial ecology, which of course is my background. So, and that people have in aquariums. Well, we want to be more diverse. Well, first define diversity, and do you, and things like that. And then the second thing, because now you have this tool, genomics. You can take a sample, you can send it to a lab, and they can tell you, well, these are all the species or genuses, or a lot of cases it just becomes back unknown. This is what was in there, and this is a relative ratio. Okay. Doesn't tell you what they were doing. We have to make guesses of what they were doing. Then the other thing you look at is you come back and you look at that list and check how many we can grow. And I guarantee you it's not very many of them. We're trying, but doesn't mean that we're successful with that. So when someone says, "Oh, well, I've got this great mix, I hate the word magic, any product that has the word magic attached to it, throw that away." Personal opinion. There's no one, and I'll include us. We're not able to grow all the different bacteria that we can identify when we run genomic samples in an aquarium. It gives us a target of, a goal or a pathway that maybe if this is, the organisms that are the most dominant, those are the ones that maybe we should grow. But it takes a lot of experimentation. If you disturb the tank, do those species numbers change? If you do this, do those species numbers change? And more important,
species numbers the same if you have fish from the Caribbean versus fish from the Indo-Pacific or, freshwater regions?
exactly.
I assume they're not the same.
We don't know.
Oh, still so much we don't know.
When it comes to the microbial world, there is so much we don't know. We don't know who they are. We're getting better at that. We don't know what they do, and sometimes bacteria have to be in consortiums. They have to be groups of bacteria, and that's what they originally thought with the nitrifiers. Turned out to be false, but there are types where you have to have a couple of different bacteria to get the process you need done. We don't know that. And then how to actually grow them in a lab in large numbers, we're not very good at that either. So we're in huge infancy here when it comes to all this knowledge, which makes it a lot of fun. But also, as a consumer, you want to be careful about marketing claims that say, wow, you get this and you're going to reestablish all this huge diversity that you need in your aquarium. That's bunk. Okay. Nobody knows what the ideal bacterial diversity is in any aquarium. It just isn't happening. The bacteria we grow, because you can just go, well, Dr. Tim, what are you doing? Well, I know that the bacteria for the nitrifiers come from aquariums, and I've published and shown that they're important to start up that phase. And now through the years, the hundreds of thousands of people that have used it have been able to cycle their tank. And so that's good evidence that it works. Now, once the tank is set up with the waste away bacteria, again, isolated from aquariums, and when you put them back and you have them in an environment that they can grow, because it didn't work. Well, you have no phosphate and you have no nitrate. They're not going to work. We don't say they work in all cases. We don't say they're magic. We don't say they're the end all be all by, bacterial diversity. They're there for specific tasks: reduce organics, reduce nitrates and phosphates. But it doesn't mean that your system is perfectly balanced, because nobody can define what perfectly balanced is. So I guess the overall message is beware of scientific Trojan horses. How's that?
I like that.
Just thought that one up. But we as a company try to be honest and fair and grow and talk to people, and we don't. I've said it lots of times. If we don't know, we don't know. Doesn't mean we can't know. Doesn't mean we're not trying to know. But when you look at the basic principles that are, because microbial ecology, call it diversity, all these things are very topical. I look at the forums and I cannot comment. I just don't have enough time in a lifespan to correct all these errors. So that's part of this podcast is to discuss, and at some point, Hillary, maybe we've talked about this, a whiteboard series or something.
Oh yes.
On ecology and microbial ecology, just the simple principles, the basics. And if you're interested, there's this whole thing. It goes back to theory of island ecology, where,
oh boy,
you know where I'm going with this. we're going to tiptoe into this rabbit hole. But in the 70s, there were a group of studies done, where these ecologists took these little islands, and they weren't very big, off the coast of Florida in the Keys. And they painstakingly tried to count and identify all the different species. And I'm not talking microbial, because at that point, bacteria, or that black box that I've talked about, nobody really knew how to count them, how to identify them, what they did, or anything like that. So I'm talking about insects, mostly birds and things like that. And then they figured out what all these islands had, got kind of a ratio, and then they depopulated the island and watched, and over the years, what recolonized those islands. Did it come back the same? Was it different? And wrote lots of books and papers on that. And as I said earlier, the Earth was dominated by dinosaurs. There can be no debate on that. I mean, you see them all over the place, right? And they were huge. And then in the span, a very short time period, as you measure, Earth's lifespan, they were gone. And that was, the big asteroid that hit. Why didn't the dinosaurs come back? I don't have an answer. But now, humans came, which is, not when eventually came to humans, but the system Earth is the system, became dominated by what eventually became mammals. What happened? What changed? There's lots of questions if you're in that philosophical mood. What originally led to dinosaurs being the dominant species? Did they eat everything because they were huge, and some of them were carnivorous and nasty if you believe the movies? Well, they did have big claws and they were huge. There's no doubt about it. But they ate everything. And I don't have an answer to this. I don't know. I'm sure a lot of people have pondered this. I can't say that I've read anything. That would be interesting if people have comments and can point us towards that, because that would be interesting to know. But, dinosaurs didn't come back. And the point of that is, if you perturb your aquarium, initially, maybe it doesn't come back, which is good. If you got cyanos or dinos, you're trying to be that force and you've got to get rid of it. But it's not going to become more diverse over time. That's not what happens in nature. That's just not what happens. So, have I made some clear points, Hillary, or have I just rambled and confused everybody?
I thought it was very clear. I thoroughly enjoyed this conversation.
It doesn't always have to be about nitrifying bacteria.
I do have a question for you. A hypothetical question, because like you said, we don't know a lot of stuff. A couple of years back, I think it was Tycho Blair that was trying to put together ecosystem habitats, basically, that were very specific. Do you think that in the future things like that would be the trend? Because we've talked about how, what would be in like an Indo-Pacific tank versus a Caribbean tank versus, a cold water tank. The microorganisms would be different. Do you think in the future that people would have more success if they had more, I don't want to say species specific tanks, but along those lines?
I definitely think so. And as we've talked about, aquariums that have set up cold water tanks, they were never very successful at getting nitrification going. And then what happened? Researchers discovered that once you're below 50 Fahrenheit, 10 degrees C, the microbial habitat changes, and it's dominated by ammonia oxidizing archaea rather than ammonia oxidizing bacteria. But for your first question, would people go for this? I don't know. People kind of choose for colors and looks and things like that. I have always tried to keep where I didn't mix South American fish with Asian fish, whether it was fresh water, or salt water. I like to have fish that would naturally appear. That's why some of these paintings where they have the whales and the dolphins and all these type of fish swimming all together. Nice colors, but I guess the ecologist in me can't see that or doesn't want to see it.
I have a couple of purses that have fish patterns on them, and they have like freshwater angelfish and saltwater environments. I'm like, no, that wouldn't work.
Yeah, well, I don't know that I have the images anymore, but when Dr. Tim's first started, we had a graphic artist, and they seriously put discus in a saltwater tank. And I said, no, you can't do that. They said, but the colors go together. It looks perfect. I'm not removing them. Well, I own the company and I'm paying your paycheck and you're removing them. They had a rainbow trout in a freshwater tank, which at least it was fresh water, but who keeps fresh water in their home, rainbow trout in their freshwater aquarium at home? Not too many people. And this isn't a knock. It's not my fish, style of fish, but the glowfish. But they get a lot of people interested. It's the same thing when people talk about zoos and aquariums. It gets people interested, and when people are interested, they get concerned. When they get concerned, then you can get them to call a call to action to preserve forests, to preserve environments, to preserve different things. If they don't see it, they don't know it, they don't care about it. It's kind of my philosophy. So there's a tool there as long as the animals are kept ethically and healthy and fed and cared for, which is definitely the case more and more these days. And it's the responsibility of the hobbyist too. If you keep an animal, and I'm talking about, dogs, cats, fish, any animal, if you're keeping that animal, you're responsible for that animal, and you should be giving it the best care that it can get. That's my feelings.
Absolutely.
Yeah. But definitely, to get to your question, I mean, I've always liked those geographically right tanks. With the bacteria, the bacteria are pretty much the same that I've seen. They're not so geographically isolated, because I know, like the Nitrifiers, the Nitrospira, when I first published my paper on that, and I was the first one to show what it was. Well, there were three other groups. Two were in Europe, and one was in Australia, and the organisms were, pretty much the same. When it comes to bacteria, where do you have one species versus another species and things like that? But they were definitely closely related, because what can happen is called geographical isolation that leads to new species. Something happens where a group is in a geographical area, a cavern, something happens, a lake forms where they cannot get physically together. And over time, what one species can evolve into two species. And I mean, the classic case of that's the Galapagos Islands and the Darwinian finches and things like. I just, to my mind, it looks, correct geographical fish aquariums look best, but I'm not against the other one. If that's what you like and that's what you care for, it's fine with me.
Okay, here's another question for you. Do you think that technology has improved, that we're able to see more with respect to microbiology and, some of these bacteria, that there's something that we may have missed because the technology wasn't there?
Oh, that's 100% true. We can definitely see, and by different techniques, maybe not with our eyes, because you can't see bacteria with your eyes very well. Not all of them. The problem, the issue is, what do they do? And that takes a lot more work. Yeah,
they do.
Well, you see these bacterium. Do you really know what they're doing? You can get a list. I could call up on the computer here a list that people send me, that this is all these bacteria that were isolated. I sent a genomic sample in. This is what came back. Okay, what are they doing? We don't know.
Just hanging out, drinking coffee.
That's it. But that's and that's what we don't know yet. More and more, we're getting there, but we don't. We tend to do that even in nitrifying cases, and there's some classic studies that I reference in some papers that I've written, where these researchers, they just had it in their mind. It had to be Nitrobacter winogradsky. And they knew what Nitrobacter winogradsky looked like because that's been known since the late 1800s. And they did all this electron microscopy in an aquarium. This was an aquaculture facility, biofilters, and they couldn't find it. And their conclusion wasn't, well, maybe Nitrobacter winogradsky isn't the nitrite oxidizer, because they knew the system was oxidizing nitrite. Their conclusion was their techniques weren't good enough to find Nitrobacter winogradsky. Well, the answer was it wasn't there because that's not where it grows. Your techniques were fine. But, we have that bias. Well, this is what's supposed to be there. And that's where, now genomics, but, when I started in microbial ecology years and years ago, using molecular probes and what are called culture independent methods, you didn't have to culture anything. In high school, or you've seen it, you grow the petri dishes. Nitrifiers hate petri dishes. If you want to grow nitrifiers, you're not growing them on petri dishes. And the petri dish, who says it's got everything that can grow all the bacteria that are in the sample? And it doesn't. It grows what it grows, but what it grows is not what dominates. It gives a very biased result. Culture independent techniques are where we just take the sample, extract the DNA. Now you can just send it in and get a biogenomics test. And the issue there is that in environmental samples, there can be such a wide range of certain bacteria that you get a lot of unknowns because we don't have a database for them. They haven't been named. We don't know what they do. But that makes things fun and opens up lots of opportunities. So stay tuned. It's a good time. It's a fun time for microbial ecology, and it's definitely important. Microorganisms, bacteria, archaea, all these things definitely rule and will be here long after we humans screw this place up. Not to be too downer on it, but them and cockroaches, right? To circle back to the original thing, you do need to add bacteria to your tank if you see there's problems, and we've done this, we see this, it shows. People will come up and they'll go, well, what do I need to add? My first question is, what's your issue? If your tank is doing well and you like how it looks, it doesn't have algae, it's not a lot of work, you're not getting, it looks nice, leave it alone. You don't have to always add something. And, the salespeople just fainted when I said this, but that's just the truth. So you don't have to intervene. And especially I've, seen this a lot in, I think saltwater tanks that are dominated by corals. Why? Because we're not adding a lot of food. And when you're not adding a lot of food, you're not adding a lot of what's pollution. Think about it. You've got an aquarium and you're fresh water and it's full of fish and you're adding lots of food each day. That becomes pollution, whether it's ammonia that becomes nitrite, nitrate, it's the organics, all that stuff. And I've run coral reef systems where you didn't add a lot of food. Dosing bacteria is minor compared to the organic inputs of dosing, flake food and pellets foods and things like that. But if you have an issue, cyano, dino, hair algae, things like that, yes, I grow bacteria, but I can promise you chemicals are a temporary fix that are really just going to lead you down a path of pulling out your hair and spending more money and no long-term cure. Bacteria offer a long-term cure when combined with knowledge of the water chemistry that you need to get to and how you can get there. And that's kind of what this whole series of podcasts is, to help you when you have problems. if you don't have problems, grab a cup of coffee and enjoy.
That's a good note to end on.
Yes, I think so. So there's not always a problem that has to be cured.
Nope.
Okay, so hopefully I spiked your interest and we get lots of questions on this, and we can do some more sessions on just basic ecology and microbial ecology and how that pertains to your aquarium. Of course, I find it fascinating. I got a PhD in it. so fascinating. But it's just a field that new discoveries all the time and interesting, and definitely applies to the aquariums. So to be continued. Any last thoughts, Hillary?
I hope you guys want to continue this because I'm fascinated by this.
So we will. Well, you and I decide what we're going to do, right? So
exactly.
That's it. Now, you, the listener, can also decide by commenting on social media, suggestions, info at drtimsaquatics.com. We definitely read them all. Well, Hillary does. And, we like input and comments and things like that. So thank you very much for listening. This has been another Dr. Tim's Aquatics podcast with Dr. Tim and Hillary. Good fish keeping.